using trig ratios to determine the length of a side. So in example 1, we're going to find the lengths of the opposite side and the hypotenuse in the following right triangle given the following ratios. So we know what opposite over hypotenuse is. We're given that ratio, which we know is the sine ratio. We're given adjacent over hypotenuse, which we know is the cosine ratio. And we're given opposite over adjacent, which we know is the tangent ratio. Now the information that we have here, let's label our sides. This is the side adjacent to angle A. This is the hypotenuse. And this is opposite angle A. So I can't use the sine ratio because I don't know opposite or hypotenuse. We can use the adjacent to angle A, the cosine ratio, to solve for the hypotenuse, or we can use the tangent ratio to solve for the opposite side. And as a matter of fact, we're actually going to do both. So we're going to start off by using this ratio. We'll move over here. So we know that adjacent to angle A is 5.8 divided by the hypotenuse is equal to 0.559. Okay, to solve for hypotenuse on the bottom, we're going to multiply both sides by hypotenuse. So 5.8 is 0.559 times the hypotenuse. To isolate hypotenuse, we'll divide both sides by 0.559. So hypotenuse is 5.8 over 0.559. And I'm going to punch that into the calculator. So turn it on. Oh, and one thing too, since we're doing trig, when I turn this on, I want to set it to degree mode. So we'll do that. Okay, quit out, and I want to go 5.8 divided by 0.559 is 10.37, rounded to the nearest hundredth, though 10.38. So this will be 10.38 centimeters. So hypotenuse is 10.38 centimeters. Next, we will solve for opposite. We know this, so let's fill in information that we know. We've got opposite, which is unknown, over 5.8, which is adjacent, equals 1.482. This is going to be a little bit easier because all we have to do is multiply both sides by 5.8. So opposite is 5.8 times 1.482, which is, and I'm not going to haul the calculator out again, this is 8.60, and we have units, which is centimeters. Now this says to watch the Geogebra demonstration. I'm going to pull up Geogebra, and we have basically the triangle, and I've labeled these sides, and there is some slight rounding differences just based on the fact that it's not quite exact, but you can see these are very close. I can't get this to be exactly 5.8. I do have these ratios, but again, remember, it's carrying more decimal places, but we can see at the sides. We want 10.38 here, we've got 10.36, we've got 8.59, but we can see these are very close. Okay, let's move down. So here are our formulas, remember, and this is obviously available for you. And remember the mnemonic, SOHCAHTOA. SOH, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Okay, let's move on. Example 2, state the values. So state, we don't have to show work, state the values of each of the following ratios given the right triangle shown. And all we've got here is we've got angle A is 29 degrees, round answers to 4 decimal places. Okay, opposite over hypotenuse is the sine of the angle. We want the sine of 29 degrees. And let's haul out the calculator. So remember, we had to set to degree mode. Sine 29. Let's close the bracket. 0.4848. Okay, rounding to 4 decimal places. 0.4848. Sine, cos, and tan are all ratios. They don't have number or units associated with them. And the adjacent to A over hypotenuse is the cosine of 29 degrees, which is equal to, and we're going to go cos 29, enter, 0.8746, 0.8746. And opposite over adjacent is the tangent ratio. So we need the tan of angle A, which is the tan of 29 degrees, and tan 29, close parenthesis, enter, 0.5543. And what we're doing is we're looking at the digit that's in the 5th position. Okay, because if we're rounding to 4 decimal places, we look to the right of the 4th decimal place. It's a 0, so we leave it. Here it's a 1, so again we leave it. And here it's a 0, so we leave. We're not rounding up. If this were 5 or higher, this digit, then we would round up the next number. So we have 0.5543. And that's example 2. If the length of the hypotenuse of the triangle shown, which apparently isn't shown, is 15.7 meters, then use the ratio you have found. Oh, the triangle shown, that refers to the one above. That's this guy. So if the length of the hypotenuse of the triangle shown is 15.7 meters, then use the ratios you found to help determine the lengths of the other 2 sides. Okay, so this is hypotenuse, this is adjacent to the 29-degree angle, and this is opposite. So if we want to find the opposite side, we are going to use the sine ratio here. So let's write that out. We will say the sine of 29 degrees. Actually, I like formula. Sine theta. Let's be neat. Erase sine theta is opposite over hypotenuse. Sine of 29 degrees is opposite, which we don't know, over hypotenuse, which is 15.7. And we know the sine of 20, so opposite is 15.7 times the sine of 29 degrees. It said use the ratios you found, so we'll use, where to go? We'll use the 0.4848. So the opposite side is 15.7 times 0.4848, which is 7.61 meters, right? We bring in the units now at the end, and we're rounding sides to the nearest hundredth here. Although it doesn't actually say in the question, I guess, but we'll stick with what we did above. If I want the adjacent side, so let's go back up here. I want adjacent. I know hypotenuse. This is the number we're going to use, so we're going to use adjacent over hypotenuse, which is the cosine, 0.8746. So cos A, let's write it out. It's adjacent over hypotenuse. I suppose really I should have used an A here. A. Cos 29 degrees is adjacent over 15.7. Adjacent, the adjacent side, multiply both sides by 15.7. So 15.7 cos 29 degrees, which we were given, or actually we worked out, 15.7 times 0.8746, which is 13.73, and there are units. Sometimes we'll do triangles, there won't be units, but there are units associated here. So 13.73 meters. Okay, occasionally we'll get triangles. We'll just say this length is 15.7. There won't be units, and then you won't need to write down units. It would just be a length. And here it is. I'll pause if you need to pause and look at that. You can. And we'll move on. Example 4. Given that angle A in the right triangle shown, okay, so it's telling me it's a right triangle, so let's label some things here. And they told us angle A is 58 degrees. So we've labeled the right triangle, we've labeled the 58 degrees, and the length of the adjacent side, this is the side adjacent to A, is 5.2 inches. So let's label that as well. And we'll use IN for inches. Determine, which means what? Pause, show your work, right? The lengths of the other two sides to the nearest tenth. Okay, so now we do have rounding here. Okay, let's label some things here. This is opposite. This is hypotenuse. We know an angle, we know adjacent. Okay, so we can use adjacent with hypotenuse to figure out the opposite. That's the tangent ratio. So we'll say tan A is opposite over adjacent. The tangent of 58 degrees is equal to opposite over 5.2. And we're not putting units here, right? I mean, we will bring the units back in at the end. The opposite side is equal to, we'll multiply both sides by 5.2. So it'll be 5.2 times the tan of 58 degrees, which is, and rounded to the nearest tenth, 8.3. Units come back in now, 8.3 inches. So we have the opposite is 8.3 inches. To calculate hypotenuse, we have adjacent and hypotenuse. So we ask ourselves, which ratio do I use? I use cosine ratio. The cosine relates adjacent and hypotenuse. Okay, let's fill in, right? We've got the formula. We're going to substitute in the cosine of 58 degrees. Don't forget your degree symbol. Is equal to adjacent 5.2 over hypotenuse. Now in this case, the unknown that we're trying to find is on the bottom. And I'm going to give you a quick way. Well, I'll show you the slow way and then the quick way. So what we would do is multiply both sides by hypotenuse. So say cos 58 degrees times the hypotenuse is equal to 5.2. To isolate hypotenuse, we'll then divide by 58. So hypotenuse is 5.2 divided by cos 58 degrees. Okay, so here's the shortcut. What you're basically going to do is interchange these two. Okay, and you've seen that the reason why is you're multiplying and then dividing. The net effect is that you can simply interchange the bottom quantity hypotenuse with the cosine of 58 degrees here in order to isolate this, which gives us here, and solving we get hypotenuse is equal to 9.8 inches. Okay, so we have determined, right, we've shown our work, the lengths, and there's units, length units, inches, of the other two sides rounded to the nearest tenth of a unit, which does everything required for example 4. Example 5. Angelina in the hot air balloon spots a bag of money on the ground below. She radios to Brad, who is standing directly below the balloon, to run to the money bag. If the angle of depression for her line of sight is 38 degrees, so this angle of depression, and remember, an angle of depression is measured from the horizontal down, and her height above the ground is 215 meters. So this height here is 215 meters. Determine show work, how far Brad has to run. So this is the distance that we're going to determine to the nearest tenth. Okay, and it'll be the tenth of a meter because our distance is given in meters in order for Brad to get to the bag. So what we're going to do actually is we're going to complete the triangle here and say, well, this is a 90-degree angle since the horizontal is perpendicular to a direct distance down to the object here. And this is 215 meters. Then with relation to this angle, and what we want to work out then is this distance here, right? I mean, it's the same as this distance down here. What we could also have done is filled this in here and said my angle of depression is equal to the corresponding angle of elevation, and then worked within this triangle. So we're either working within this triangle here or this triangle here. In either case, we're finding this distance, which is adjacent to the 38 degrees. So this is adjacent, and the 38 degrees here, this is also adjacent. This side here is opposite the 38 degrees, or if we're talking this 38 degrees, then opposite. So in any case, we need to calculate adjacent. We have opposite. The trig ratio that we're going to use, which relates, so tan theta is opposite over adjacent, right? So the problem solving step is to figure out which trig ratio, what information do we have, which trig ratio are we going to use, substitute in what we know. So the tan of 38 degrees is equal to opposite, which is 215 over adjacent, and use that shortcut, right, which is to say that adjacent is equal to 215. No, we don't put the units on here, over, but we do have the degrees, over the tan of 38 degrees. Okay, and if you want, you can do this in two steps. This would look like tan 38 degrees times the adjacent side is equal to 215. Running off my tablet there, which would then become this. The adjacent side is 215 over tan 38. You divide both sides by tan 38. So adjacent is equal to 275.2. Bring in the units now, meters. And so Brad has to run 275.2 meters to get the, oops, gonna find where I am on my tablet, get the bag. And continuing on, example 6. Samantha is flying a kite in Glenmore Park. At one point, she has let out the entire 156 feet of string that is attached to the kite. So this is the string here. This will be 156 feet of string. The angle of elevation for her line of sight to the kite, okay, angle of elevation measured from a horizontal, imagine that line is horizontal, is 54 degrees. And the string is taut, okay, so it's a straight string, it's not dipping. Determine the horizontal distance from Sarantha to the kite to the nearest tenth. So horizontal, this is horizontal. So how far is she? So let's fill in this diagram. That's a right angle. And this is the horizontal distance, so we'll call that D. Okay, in solving a trig problem, we name sides. This is the hypotenuse. This is adjacent to the 54 degrees. Which ratio relates adjacent and hypotenuse? It's the cosine ratio. So we say cos theta. This is my formula, right? The cosine of an angle is adjacent over hypotenuse. The cosine of 54 degrees is adjacent, okay? That's our D value, over hypotenuse, which is 156. Okay, remember, no units here, but they'll come back in. Multiply both sides by 156, so D is equal to 156 times the cosine of 54 degrees. You do need degrees. Those are units you can't leave out. And D is equal to, you multiply that out and round, 91.7. 91.7 what? Okay, units are feet, so 91.7 feet. So Sarathana is 91.7 feet from the kite. Measured horizontally. Okay, she's 156 feet from the kite in a straight line distance to the kite. And now we want to figure out how high above the ground the kite is if Sarathana is holding the kite string at eye level and her eyes, whoops, I could draw a straight line, and her eyes, okay, 90, 156, this is 54 degrees, this distance here is 5 feet, and that's 156 feet. This distance here is 5 feet, and we're going to call this distance here, from the kite to here, we're going to call that h. So when we want the final height, the height to the ground, we're going to have to figure out what h is and then add 5 feet to it. Now, here's something we should avoid doing. We should avoid using a calculated value. In other words, I don't want to use this 91.7 value here. I want to use the numbers that were given, which is the 156 and the 54 degrees. In relation to the 54 degrees, this is opposite, this is hypotenuse. Opposite and hypotenuse is the sine ratio. Sine theta is opposite over hypotenuse. Sine, okay, we know the angle, it's 54 degrees. The sine of 54 degrees is equal to opposite, which is h over 156. H is equal to 156 times the sine of 54 degrees. H is equal to 126.2 feet. The height, okay, that's this height, the height of the kite will be that plus 5. So height is equal to h plus 5, which is 126.2 plus 5, 131.2 feet. So the kite, that's okay, the kite is 131.2 feet above the ground. Okay, we're done with that page. What's next? Okay, the did you hear about? So this is part of the homework or the assignment. So in any triangle below, find the length of x, round it to the nearest 0.1 meter, find your answer in the answer column, and notice the word next to it. Write this word in the box that has the same letter as the triangle. I will note for you that I believe there is one mistake on this. There's a rounding error, and this should be 115.4. Okay, so if you make that change, then you'll be able to work the numbers out just a little bit better. And use your outline sheet. You will see that there is some textbook work, and there is a note on the outline sheet about one of the questions. some information that's not given in the book and should be, so that you can fix that. All right, we're done.